Hello Internet, I am your designated dunce and I will be explaining every setting in AI ToolKit in a simple way that hopefully anyone can understand, and I will be including visuals where applicable to try to make the explanation even more understandable for you. This video does have chapters, so if there's a specific part that you want to skip to, it should be marked down below on the timeline. Now you guys know the drill, I will be cutting out as much fluff as possible to focus on giving you guys purely simple to understand information, but before that happens, I get to ramble for a bit, so skip to the next chapter if you just want the guide. So apparently I'm doing something right, because it's been like 2 weeks since I last uploaded a new video, and I'm still gaining subscribers, so thank you to everyone who's been subscribing. And if you aren't subscribed, and this video is helpful to you, then how about you do me a solid and subscribe? It's right there. Do it. All the cool kids are subscribed to LateNightAI. Quick disclaimer, not all of the information presented in this video is guaranteed to be 100% accurate. I am not a data scientist, and the research I did for this was broad and shallow because there's a lot of information to go through, but I am doing my best to make sure that I give you guys accurate information. It's just that there's a non-zero chance that some of it might be incorrect or slightly off. That being said, let's get into it. Alright, so after you launch your AI Toolkit and you go to New Job, you end up on this page right here, and the first thing we're going over, Job Settings. This one will be simple. Here you have your training name where you can put in your LoRa name. If you have a custom trigger word that you're using for the LoRa, I would personally suggest putting the custom trigger word as the LoRa name as well. That way you don't forget what word to use to trigger the LoRa. Next up, you have GPU ID. Here, you can select what GPU it's going to use for the training, if you have multiple GPUs. I do, so I have this option. Now, if you're on Windows you can open up Task Manager and come into Performance, and this will tell you what your GPUs are. Now, this, if I was running this on Windows, I would only have this option down here for your GPU 1, my 3090, but this is running on Linux. Let me show you how to figure out what GPU it is on Linux. Alright, so I've just SSH'd into my Linux server, and then if you're already just on Linux and not connecting to a Linux server for it, and then you would just open up your command line interface. You're going to want NVIDIA-SMI, hit enter, and this will give you the information on your GPUs. So here you can see this is GPU 0, and this is GPU 1. So you'll notice I currently have training running on GPU 1, but GPU 0 is doing nothing. And that's how you can figure out what GPU is what. Moving on, we have trigger word. This is basically where if you didn't already have a trigger word in your text files that go along with your training images, you could set one here. So by putting a trigger word here, as I understand it, this will now basically, after you click create job and run it, basically take this trigger word and add it to the start of every text file that you have with your training data, making it the trigger word. So if you already have one in your text files, you don't need to do anything with this. If you don't have a trigger word set in your training data and you would like to have one, you can add it here. Moving on, we have model configuration. Here, you can choose what kind of model you want to train a LoRa for. You've got Chrome, Flex, Flux, Context, OmniGen, SD15, SDXL, and WAN options. Now, it's worth knowing that some of the settings for SD15 and XL are different than the settings for the other larger crazy models. So I will also be covering those. Let's start with SDXL. Here, this just tells it what kind of model you're training, and then here, I can either paste the path to my checkpoint, or I can just leave it as is, and AI ToolKit will download the default normal base model SDXL and train on that. Now, for SDXL, if there's a specific checkpoint I want to train on, I would just open up to wherever that is. I would click on it, right click, and then I can say copy as path, and then I can just paste it in here. And ta-da, it now has the path to the checkpoint that I want it to train on. So it will now use this checkpoint for the training. That works for SDXL and SD1.5. However, it gets a little more complicated once you start getting into other things like Flux Context, because Flux Context needs some extra files for its training. So you're either going to have to download Flux Context yourself and make sure you get all the extra files it needs, or you could just select it, leave this as is, and let AI ToolKit download it for you. Personally, what I've just done is I've just let AI ToolKit download it for me. Yeah, it means I had to download the Flux Context model again, but it also means I didn't have to deal with all the crazy jargon and trying to figure out what files I had and what files are missing to get it to train. But now that we're on something other than SD15 and XL, you'll see that we have quantized transformers and text encoders down here. As I understand it, transformers is what teaches the visual data and any new words that the model doesn't already know, whereas text encoder will kind of be like a small dictionary that goes along with the LoRa to redefine words that it already knows to make sure that your prompt, specifically that you had in your training data, is understood and not just overwritten by any pre-existing data in the model itself. Now, a reason you might want to turn text encoder off during training, other than being an absolute mad lad, is text encoders tend to take up a fair bit of space on VRAM. Some of them are 5 to 9 gigabytes of VRAM that they take up. So if you don't have the VRAM for it, you might want to turn text encoder off as long as you're fine with having to use a very specific custom trigger word to trigger your LoRa. So if I want to train a flux LoRa on pictures of a red truck with transformers on but text encoders off, I would have to use a custom trigger word that the model would not know. That way it could associate my red truck to the trigger word. If I just said red truck because text encoder is not on, it would not be getting any information about what to use to trigger my red truck because it already knows what a red truck is. But if I turn text encoders on, then I can just basically say my red Chevy truck. And even though the base model might already know what a red Chevy truck is, having text encoders on gives it a new dictionary that says, you did know what a red Chevy truck is, but actually this is what red Chevy truck means now. Moving on, we have target configuration. Here we have an option for a LoRa or a loker. Now, a LoRa is a low-rank adaptation. It is standard and very common. Loker is a low-rank Kronecker product approximation. It's basically a LoRa 2.0, but it's not always supported by every image generator and whatnot. It is supported by things like Automatic 1111 if you're using the Licorice extension, and Comfy UI. So if those are what you use, then you might want to train a loker instead of a LoRa, because lokers are a bit better than LoRas. But if you're planning on distributing it to people everywhere, you might want to train a LoRa to avoid having people go, it's not working, it's not compatible with my setup. If you want the highest quality that you can, loker's what you want. Below that, we have linear rank. Now, linear rank is kind of like how hyperfixated your LoRa becomes on your training images. Basically, this is kind of telling it like how focused it needs to be on exactly the training images. So if your LoRa, or loker, starts replicating your training images exactly and not giving you much versatility in it, you might want to set your linear rank to a lower setting. Or, if it seems like it's really just not learning anything at all, you might want to try setting it to a bit higher setting. Now, what you're really going to want to set this to is also going to depend on the data set that you have. If you have a small data set, you might want to set it a little lower. If you have a large data set with lots of images, you might want to set it higher. It's all going to be kind of correlating to what your data set is. For the most part, I would say just leave it at 32. It seems to work pretty well. And if it doesn't, then just adjust it. If it's replicating your images too similarly, turn it down. If it's not working very well, turn it up. Now, you'll notice this is one of the things that there's different settings for the SD15 and XL. With SD15 and XL, we have the conv rank. From what I understand, the conv rank kind of controls things more like textures, styles, and structures. So if you're trying to train a LoRa that has a specific art style, you might want to turn this up. So the linear rank is kind of a little more on how it turns the words into your image, and the conv rank is kind of more focused on how the image is made. Once again, I normally would not mess with it. 16 is just fine where it is. Now, if you are trying to train on a diverse set of data to get like a character and it's copying over the art style of that, you could turn the conv rank down, and that should help to stop it from copying the art style of that character. Or, if you're specifically trying to train on something like building structures or a specific art style, you could turn this up to help it lock on to that structure or art style. Moving on, we have save configuration. The first thing you'll see is data type. We have BF16, FP16, FP32. Now, it defaults to BF16, which is perfectly fine and honestly one of the best options here. Now, the difference between BF16 and FP16 is BF16 does its math for the LoRa training in a more stable way than FP16, so BF16 is actually more stable and less likely to crash than FP16. However, FP16 is technically a more precise training method, and BF16 is less precise. Now, obviously, this raises the question of how precise are we talking? The answer is you won't notice it. Like, unless you are doing some insane micro training, like, you literally will not be able to tell the difference between BF16 and FP16 for most of the training that you're going to do. And if you are able to notice a difference, it's going to be extremely negligible. So, for the most part, unless you have something that you need to get very specific on, and you've already done all your research on the best way to do it, I would say go with BF16. Now, you could also go with FP32. This is going to be very precise and very stable. However, it's going to use a lot more VRAM and take a lot longer than training on BF16 or FP16. But if you are just going for the best quality you can possibly get at the most stable, non-crash learning rate, FP32, it'll work. For the most part, BF16 is all you need. It's stable and fast and will work. Moving on, we have save every. This tells it how many steps for it to train before it creates a checkpoint. So currently, it's just default set to 250, which is fine when you're doing something like Flux, Chroma, context, and whatnot, but not that great when you're doing SDXL or 1.5. If you're doing SDXL or 1.5, you'll probably want to set this to something closer to 100. Now, important to know is if you change your save every, you also want to come down here to your sample configuration, and sample every, you'll want to change it to match. The reason is because every time you hit this point, it creates a saved checkpoint of the LoRa you are training, and then sample every will create a sample image at every time you hit that set amount of steps. So you want these two to line up so that when it creates a saved checkpoint, it also creates sample images to go along with that saved checkpoint. Now, the step that it's counting is actually this right here, and we'll get into this a bit later, but basically you want to make sure that these numbers work with the number that you have in here. So 100 can go into 3000 just fine. Now, if I set this to something really weird like 77, that might cause some problems. They don't match in too well. Now moving on to max steps to keep saved. Currently it's set to 4. This tells it how many checkpoints for the LoRa it should hold on to. So basically right now, set to 4, it will hold on to the 4 most recent checkpoints that it's made for the LoRa. Now I have save every set to 100 and I have steps set to 3000, which means it would roughly create somewhere around 30 checkpoints. However, it would only keep the 4 most recent ones saved. So I would not have all of those checkpoints. If I wanted all of those checkpoints, I would set it to 30. Now, obviously, if I have it set to 30, it's going to create and save 30 different checkpoints, and that can start to take up a fair bit of space. And also, this is far too high training for something like SDXL. We would really be doing this somewhere between 100 or 1000 to 1500, which means I would not need 30. At most, I would need 10 or 15. Now, normally, when you're doing training, the first 5 LoRas or so, they're not very useful. It's usually after you start to get past the 5 checkpoints that they start to look like, hey, this is something I could use. So set your max checkpoints to keep saved to whatever you think is going to be best for you. So if I'm doing 15,000 steps and set it to 10, this will probably work just fine and give me some checkpoints that I can use. Just remember, it's only going to keep that many saved, so if I'm doing some crazy training, like 15,000 steps, I'm going to lose access to a lot of those trained checkpoints, especially if I just set the training and walk away. So make sure that you set your save every to whatever you need it to be, or you're here monitoring your LoRa training as it goes to make sure that you find the checkpoint that looks good. Now moving on to training configuration, the most daunting part of this entire section. We'll start with batch size. Batch size is basically the amount of pictures that it's going to show the LoRa at once during the training step. So basically, it's like it's holding up however many you set them. Now, for the batch size, it will depend on the amount of VRAM that you have to what batch size you can set it to. If you have 6 gigs of VRAM, you can do normally depend. If you're doing SDXL, I don't know about Flux and other things, but with SDXL, you can do a batch size of 1, which is just 1 image, or 2. If you've got like 8 gigs, you can normally do somewhere between 2 to 4. If you have 12 gigs, you can do 4 to 6, and if you have 24 gigs or more, you can do something like 8 or however many you want, depending on what VRAM capacity you have. And this will basically be holding up and showing it 8 pictures at once to give it a good idea of what it's supposed to be learning. Now, the higher the batch count, the better your LoRa is going to do at learning the concept you're trying to teach it. If my batch size is 1, it's like I'm handing the LoRa 1 picture of, let's say, a red Chevy truck, and I'm saying, hey, you need to learn this, and then I send it out into the world to go find it, and it goes and it sees another red truck, and it goes, hey, that looks kind of like my picture, even though the truck it found is something like a red Toyota instead of a red Chevy truck. It's got the general concept, but it's missing some of the finer details. Now, if I gave it 8 pictures of a red Chevy truck and send it out into the world to go find me a red Chevy truck, it has 8 reference pictures of which it can look at and figure out the finer details. Not only does it need to look like a red Chevy truck, it needs to have their Chevy logo and other things in there. So that way, it will go out and be like, oh, that's a red Toyota. That's not a red Chevy. That's a red Ford Ranger. That's not a red Chevy. Oh, look, I found a red Chevy. So the higher the batch size, the better your LoRa is going to be, but it requires more VRAM. So idealistically, based upon whatever your VRAM limitation is, you're going to want to set the batch size as high as you can. It also depends on your dataset. Do not set the batch size higher than the amount of images in your dataset. Normally, you need to have a good amount of images in a dataset to get a good LoRa. If for some reason you're training on a tiny dataset of, say, 5 images, but you set your batch size to 8, you're going to encounter problems. Do not set the batch size higher than the amount of images in your training set. But for the most part, you should always have more images in your training set than what you can set your batch size to. Moving on from that, we have gradient accumulation. Now, the gradient accumulation is kind of like how to get the same results as training on a higher batch size without having all the VRAM. It will take longer, though. So if I set my gradient accumulation to 8, it will be the same as if I was training on a batch size of 8. Now, the way this one works is instead of showing the LoRa 8 pictures at once, it's going to show the LoRa 1 picture at a time 8 times. So it still gets the same amount of information as if it had been shown 8 pictures, but it's going to take much longer because it has to pass the LoRa 1 picture at a time, but it's going to give you the same results as if you had your batch count set to 8, but it's going to take longer. Now, presumably, I should be able to do something like a batch size of 2 and a gradient accumulation of 2, and this would be technically combined to make 4. So it would basically do a batch size of 2, so it will show it 2 images at once, and then it will do 2 rounds of showing it 2 images, meaning it sees 4 images total, so it would be like having a batch size of 4 before it adds that data into the LoRa. But for the most part, I would say if you have a GPU that can handle at least a batch size of 4, just go ahead and train on a gradient accumulation of 1, batch size 4. Or if you can go higher than that, go higher. Next up, we have steps. We already talked about this a little, but this is the amount of steps that it will do before it finishes training. Now, if you're doing something like an SDXL, you normally wouldn't want to go anywhere past 2000, because SDXL does not need that much information compared to the larger models like Flux or WAN or the other things. So, if you're doing an SDXL, set it anywhere between 1000 to 2000. If you're doing something like Flux, you're probably going to want to either leave this at 3000, or if you feel like the training is not getting to the point that you want it to, set it even higher, 5000. Now, there's other things such as WAN, where you're going to want to probably set this even higher because it's going to need a lot more training data. I haven't messed around with training any of the WAN LoRa's, so I would not know specifically right now, but I would say if you're training anything other than SDXL, 3000 is a good starting place, and if it feels like it didn't train far enough, just come and edit the training settings, come back in here and increase it to 5000 or whatever, and start the training again. Just once again, keep in mind that you need to make sure that your save every and your max to keep save, as well as your sample steps, correlate with your steps. Moving on, we have the optimizer, and here we have an option for Atom W8-bit or ADA factor. Now, basically what this optimizer is it's kind of like the director that tells the LoRa, hey, you're doing a good job at learning what you're supposed to, or telling it, hey, you suck at that, let's try to figure out how to do better. So, what you really need to know about this is Atom W8-bit is going to be a better optimizer, as I understand it, than ADA factor. But the difference is Atom W8-bit is going to be a more VRAM intensive than ADA factor. So if you're training on something like Chroma, Flux, or something else, and you have VRAM issues, go with ADA factor. It's going to work much better within your VRAM restraints. If you're training on something like SDXL, Atom W8-bit is going to do better because you're presumably not as VRAM constrained. Now, if you're training on a massive dataset, ADA factor actually might do better than Atom W8-bit because ADA factor is designed to work better with huge datasets. If you're training with a smaller dataset, Atom W8-bit is probably going to outperform ADA factor. But once again, it's really going to mostly come down to your VRAM constraints. If you're able to use Atom W8-bit for most of the LoRa training you're doing, that's probably going to be what you want. If you are running into VRAM issues, try ADA factor. It might work better with your VRAM limitations and dataset. Next up, you have learn rate. Just like it sounds, it's essentially the rate at which it starts to learn the things that it's trying to train on. For the most part, it's set to a pretty good setting for most things. If it's having a hard time learning your dataset, maybe increase it a little. You could make it 15, or maybe even bump it up to 2. You'll have to play around with it and figure out what works better. But If you set it too low, it won't learn very well. If you set it too high, it will instantly overlearn and turn your LoRa into a jumbled mess. For the most part, unless there's some specific fine-tuning you're trying to do for your LoRa, leaving it at this is probably a safe way to leave it. Below that, we have weight decay. Weight decay is a regularization trick that gently shrinks the model's weights over time, so that they don't become too big, bloated, and start overcooking. Every time the optimizer updates the model's weights, the weight decay subtracts a little bit off of it, kind of helping smooth it out. This should, in theory, basically try to help the model from learning the exact training images so that it can apply it as a broad concept and not specifically try to recreate exact images. Personally, I really don't mess with this, but if you're having issues where your LoRa is learning specifically the exact images instead of being able to be applied as a wider concept, then maybe you should try increasing this a bit and see if that helps. Moving on, we have time step type, time step bias, and noise scheduler. Basically, as I understand it, these are the things that decide how, where, when, why, and how it adds noise into the image and then learns how to diffuse that noise into the image that it's supposed to be. Now, sigmoid type is kind of like a algebra graph shape thing, where it's like an elongated S. Basically, this will focus more, as I understand it, in the middle of the denoising process. Linear just means it's going to learn across the board basically at about the same rate. And shift, as I understand it, will make it either focus more heavily on the beginning or on the end of it. Now your time step bias is basically telling it where it should be focused. For balanced, it's kind of like linear, where it's going to be trying to learn equally across it. High noise means it's going to focus more on the beginning, where there's a lot of noise in the picture before it's really started to be diffused into an actual picture, and low noise should help it focus more towards the end of the denoising process, where it's mostly turned into a picture. And below that, we have scheduler type. Basically, it decides on how it's going to do noise and stuff. What you really need to know about this is flow match is meant for flux and the newer stuff, whereas DDPM is meant for the older stuff. So if you're doing SDXL or 1.5, use DDPM. If you're using any of the newer, cooler stuff, use flow match. If you're training a LoRa with a smaller dataset, you might want to turn EMA on if you want to make sure that your images are a little more consistent and you get consistent prompt behavior. Basically, what EMA does is you could kind of think of your LoRa training as like a staircase. Turning EMA on turns it into a more smooth escalator. So instead of having those larger up spikes, it'll try to smooth that out. And below that, we have EMA decay. This is basically how fast the LoRa will start to forget its old updates and listen to the new ones. So basically, EMA decay is kind of like the smoothing strength for how it's going to do its learning. If you want it to be a little more janky, you could set it to 0.9. If you want it to be relatively smooth, you can set it to 0.99. If you want it to be really, really smooth, you can set it to 0.999. For the most part, if you're going to use it, 0.99 is probably what you want it to leave at. Now, below that, we have unload text encoder. Now, this is another VRAM saving trick, essentially. The text encoder is only needed at the start of each training step to turn your captions into embeddings for basically learning what the embeddings are compared to the image. After that, it's not used, but it is used at every step. So if you have VRAM issues where while it's trying to learn on the images, you don't have enough VRAM, you could unload the text encoder to free up more VRAM for more images and training on that. But it's going to have to reload the text encoder every time it moves up a step. So if you turn on unloading the text encoder, it's going to add a fair bit of time to your LoRa training, especially depending on what type of storage device you are working with. If you're working with a hard drive, dear Lord, you are going to add a substantial amount of time to your training, because a lot of the text encoders, especially when you're working with Flux or Chroma and these other things, they're 5 or 9 gigabytes, meaning it has to load that extra 5 or 9 gigabytes into the VRAM. And most hard drives are pretty darn slow, meaning loading up 5 to 9 gigs off of a hard drive is going to add a substantial amount of time. Now, if you're on a super fast solid-state drive, SSD, or even better, an M.2 SSD, it might not add that much time depending on what kind of speeds that hard drive or that SSD has. So, play with that at your own peril to save on VRAM. If possible, it's best to leave it off. Next up, we have regularization. Differential output preservation. If you turn this on, you will need a dataset for it. So you have to mark that dataset as a regularization dataset. Now, what this will do is basically you can give it a bunch of pictures of things that it's not supposed to change to make sure that it doesn't change those things. So if I train a LoRa on a red Chevy truck and I find that, hey, when I turn my LoRa on, it's turning other trucks into red Chevy trucks also, I could turn it on, I would change this class preservation to truck, and I would give it a bunch of pictures of normal trucks that are not a red Chevy truck. I would also make sure to caption them. But then this will help it basically be able to differentiate between when it's supposed to be making a red Chevy truck and when it's not supposed to be touching or messing with the other trucks. Now you have your DOP loss multiplier. Basically, you could set this as low as 0.1 or as high as 2. Think of it as kind of a percentage. So if you have it at 1, it's kind of like 100%. Adjust it around as you need. If you find that your dataset is still getting messed up when you're trying to edit something like a normal truck and not turn it into a red Chevy truck, but your LoRa is hijacking the term truck completely, you could turn this on. But then you would need a dataset down here with a bunch of pictures of trucks that are also captioned, and you would turn on it is a regularization dataset so that it knows that it's supposed to do this with it. You would make sure that you don't have any kind of trigger word in this dataset though. It would need to be captioned, but don't give it a trigger word. And that's what you need to know there. And now moving on to our dataset. You can have multiple datasets, as I showed earlier, and you can make one of them, or multiple of them, a regularization dataset if you need it. Now, here is where you can just simply choose what dataset you're using. And down here, you have LoRa weight. This is basically telling it how important that dataset is to the training. Once again, you can kind of think of it as percentage. So 1 is like 100%. So if I wanted to train a LoRa, and I've got some different datasets for it, let's say I have one dataset that has the character LoRa, and then I have another dataset that has something like a pose or positioning of that character, and I find that my LoRa is doing really good at figuring out what the character looks like, but a really bad job at figuring out the specific pose they're supposed to be in, I could have the poses in a separate dataset, and I could increase this to try to make it focus a little more on figuring out what their pose is. So if you have a LoRa that is doing really good at learning one thing, but kind of sucks at learning another part that it's supposed to be doing, you could divide it into multiple datasets, and then give different parts of that dataset a stronger weight to make it focus on that a little more. Next up, you have default caption. If you already have captions for your dataset, which most of the time you should, you don't really need this. However, you could also put something in here, such as red Chevy truck, and then this would be applied as a caption to every picture. For the most part, you really don't want to mess with this, other than if you have something that you need to be applied to every picture that you forgot to add into your original captioning of the dataset. Next up, you have your caption dropout rate. Basically, this is kind of like telling it how strong the trigger word needs to be versus the LoRa always being on. What it will do is essentially remove different parts of the captioning from it during training so that it can figure out how to use it even without always having to necessarily have that exact trigger word set up. If you set this to 0, you're going to have to use the exact trigger word that you use to train your LoRa. If you set this to 1, it's basically going to always be on. So if you have like a style LoRa or something and you want it to always be active without having to turn it on, you could set this to 1. Or if you just want to make sure that it needs your trigger word to work, you could just leave it at 0.05. Now we already went over what regularization is, but here's what cache latence is. Basically, if you turn this on, it's kind of like telling it to do meal prep. So instead of preparing everything it needs every day, or every time it does a step, it will just prepare it once, and then recall it when it needs. Now, this is useful for speeding up the training. However, it will start to eat up a lot of space on your hard drives. So if you turn it on, it will pre-compute and save all the images into a latent form that it understands. However, those latent image forms that it's going to save can range from 30 to 60 megabytes per 512 image. So if you have a data set that's 1,000 images or something, and they're only 512 by 512, that could take up 30 to 60 gigabytes of storage. And those latents will not be deleted after the training's done. You will have to go in and manually delete them. But it will skip the step of having to convert those images into latents every time it needs them. So, if you don't care about your storage, or you have a large amount of storage to just throw away, you could turn this on, and it will speed up your training. However, if you don't want to have to go and clean a couple 100 GB of training data off your drive after you've trained a good couple of LoRa's, you can leave it off. I don't know exactly how much of a speed difference it actually makes, however, unless you're training on a very large dataset, it really shouldn't make that much of a difference. So I would just leave that off and save my hard drive space. Next up, you have resolutions. Now this is basically what size images it's allowed to train on, or what bucket size of images it's allowed to train on. So what happens when you give it an image that is not one of these sizes is it does something called bucketing, where it will shrink that image down to something that matches to one of the images that's already selected. The way it works in AI ToolKit is it will only shrink the images, it will not make them larger. So if I gave it an image smaller than 512 in height or width in some form or fashion, it wouldn't know what to do with it and would not work very well. But if I gave it an image that was 999 by 999, it would shrink it down to 768 by 768. Or if it was smaller than 768, it would shrink it down to 512. So if it's smaller than 512, well, it shouldn't be in a data set to begin with. It's going to be terrible for training a LoRa on and just not be functional. Now, AI ToolKit allows us to train up to 1536 by 1536 image size as the max. For the most part, though, a lot of LoRa training and stable diffusion stuff is either going to want to be trained on 768 or 1024. Now, you could turn all of these on if you wanted to get crazy with it. I would never suggest turning on 256, but it will basically bucket or shrink that size image down to have a max width or a max height of 768 or 512. If all of your images are bigger than 768, then you wouldn't have any images that end up at 512. It's not even worth having on. But for the most part, you're only really going to want 1024 and 768, really, unless you're training an SD 1.5, at which point, I guess you would train on 512. Now moving on to the final part, we have sample configuration. First up, we have sample every. This tells it how many steps it should go. These are the steps it should go before it makes a sample image of what the LoRa is doing. You want to make sure these match so that when it creates a saved checkpoint of your training, it also has images to show you what that checkpoint's looking like when it's in use. Now below that you have flow match and DDPM again. Once again, if you're using SDXL or 1.5, you're just going to want to go with DDPM. If you're using the other things, go with flow match. You have guidance scale that basically tells it how strict it needs to be paying attention to your image prompt. For the most part, 4 to 6 is about what you want to play with. You have sample steps, which is basically how many steps it samples out to make your image. 25 is pretty fair. You could set this as low as 18, but then you're going to get a lower quality image output, and depending on what kind of model you're using, it might not be happy with that. Here is where you decide your width and height of the image that it makes. So 1024 by 1024. You could shrink this around if you wanted a more rectangular image and set it to something like 768 by 1024, or set that to however you want. I would personally not set it to anything higher than 1024 to avoid causing issues with just it trying to figure out how to generate the image, or taking a extremely long time to generate the image, or better yet, running into VRAM issues of not having enough VRAM to be able to compute an image that big. Next up, you have the seed. It defaults set to 42. You could set this to anything you want. And if you have walk seed on, what that means is every time it has a new prompt, it adds +1 to the seed. So, woman with red hair would be, I'm going to make this a simple number. Woman with red hair would be 51. Woman holding coffee cup would become 52. Horse, and if that is a DJ, would become 53. And every time it went through and used those prompts, it would make sure to use the same seed. So every time it made a new image with woman with red hair, it would still use 51. Woman holding red coffee cup, it would still use 52, and so on. Generally, it's a good idea to have walk seed on to make sure that if you have prompts that are somewhat similar, they don't have the same seed, so you still get a relatively diverse image output. Now, down here, you can click the X to get rid of image prompts, and you can also add prompts. Okay, so apparently to my current little testing here, there does not seem to be a limit to how many prompts you can have. I have added up to 32. It's a little insane and crazy. You wouldn't want to do this. Normally, anywhere between 4 to 10 image prompts is just fine to be able to look and check your LoRa and see that it's doing what it's supposed to. And with that, we have now covered every setting here in AI ToolKit for training a LoRa. Hopefully this was helpful to you. This video has taken me multiple days to record and edit. It has been an absolute nightmare compared to the other videos I've made, as well as it had a steep learning curve if I had to learn a lot of things and figure out how to simplify the explanation of what those things are. So if this is helpful to you, please go ahead and subscribe, drop a like, and maybe even throw in a comment to boost my ego.